if you will. What I'm going to look at here, instead of being within one revolution, what we did yesterday, because it had that boundary placed to it, you were bounded between 0 and 2 pi. Today we're going to take the boundary off, and you're going to look at, all right, how long does it take me to get back to the same angle? Every revolution I'm back at pi over 6. If I go around the circle, I'm at pi over 6, aren't I?
Yeah.
But what I'm looking at a little bit differently here is, for what we call a general solution, I want to write this, I'm going to write these 4 angles out in the most basic manner. So we start at our first angle. To get from here to here is X amount of the circle. You agree? Is it the same amount to get from here to here?
Yes.
To go from pi over 6 to 5 pi over 6 is how many degrees? Or how many? 4 pi over 6. To go from 5 pi over 6 to 7 pi over 6 is not. It's 2 pi over 6. They're not equidistant. The distance between on the arc from here to here is not the same as it is from here to here. Everybody okay with that?
It's congruent to its opposite side.
Right. What happens is, to talk more about what we're looking at general solution, these two values are pi apart. Do you agree?
Yeah.
So if I started here and I add a pi, I'm here. If I add a pi, I'm here. So no matter how many pi's I add, I'm going to be either at pi over 6 or 7 pi over 6 tacked on a pi. Does that kind of make sense?
Would that mean you could also say you're 5 pi over 6 or 11 pi over 6?
Correct. So what I do in terms of a general solution is I'm going to take this pi over 6 and then I'm going to add pi times n, where that n means the number of times I'm adding pi. Add a pi and here, add another pi and back, add a pi and here, add another pi and back. Okay, so if it's plus 5 pi, here's 1 little, 2 little, 3 little pi's, 4 little, 5, I'm back here now.
So n
N will equal the number of revolutions. Whether it's going to be a pi revolution, I fight for pi! Whatever. Or a 2 pi, I just made that up. Or a 2 pi revolution, we're going all the way around. Come full circle.
Hey, I made that joke multiple times in this
Yeah,
class.
nobody listens to you though.
I know.
And then you can do the, so
I
in
don't
these,
even know her name, so I
oh, we gotta get her name tag again. So in our 4 possible answers here, I don't have to write down this one because this plus pi n takes its place. Same idea with the 5 pi over 6. These guys are pi value away, aren't they? So my general solution would be pi over 6 plus pi n and 5 pi over 6 plus pi n. And that would be my answer. That's the difference between what we did within one revolution versus general solutions. How basic can you make it look? Okay? Sometimes you'll be adding pi revolutions. Sometimes you might be adding 2 pi revolutions. And there are instances that you would add pi over 2 revolutions. They're very easy to do. Okay? They're very easy. And again, all you need to be able to do is plot it into your triangles to recognize where it's going to be placed. That's it. And if you did that yesterday, okay, you're going to be fine. The problems don't change. Okay? They really don't. Yeah. So let's do this. 2 secant squared of x. Oh, I'm sorry. Secant squared of x minus 2 is 0. Okay? Secant squared of x minus 2 equals 0. And I'm going to write out the general solution. What do you do first? Add 2, good. Add 2 and then what? Good. So we have the secant of x will be plus or minus root 2. So what angle gives me the secant value of plus or minus root 2?
45.
So place it.
Oh, yeah.
Secant is your hypotenuse over adjacent. So if my hypotenuse is root 2, that means my adjacent is 1. So what's my angle? 45. So in this case, it's going to be a pi over 4. Well, pi over 4 occurs in all 4 quadrants, correct? What do you know about the ordered pairs at pi over 4 in each quadrant? They're equidistant because it's root 2 over 2, root 2 over 2, negative root 2 over 2, root 2 over 2, negative, negative, and positive, negative. The only thing that changes with those 4 ordered pairs is their sign SIGN, which means what do the pi over 4s create? A square. So these guys create a square, and what do we know about all squares?
They're cool shape.
They're cool shaped, they're equidistant, and they also have what for angles?
90.
So what do we tack on? Pi over 2. Pi over 2. When you are replicating a pi over 4 solution into all 4 quadrants, that is the only time you're adding pi over 2n. It's the only time. Okay? It's the only time. Because that's the only set of ordered pairs that creates a square. The other ones create rectangles. And that was, remember when I showed you that in the unit circle, why we were coming across with the same values? That's the whole reason. Because we can do this.
So the other ones were unit circles?
The other ones were making rectangles.
But like when you did the pi one relation thing, like it was pi.
Oh, this still makes a circle because to get from here to here, you go half a pi, 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 half a pi. It still works. Okay?
So
Yeah, this is my answer. That's the most generic as I can get. Yes, ma'am.
So every single time, like it's pi over 4, you always, it's like pi over, like like you want to get like a general solution, so it's always pi over 4 plus pi over 2, and
If, and only if, you have a plus minus. Because sometimes you can have just, the secant value is root 2. If the secant value is root 2, that's just going to occur within 2 quadrants, and then you just be tacking on a pi value.
all right, thank you.
Okay? Because they're on the same diagonal, if you will.
12.
All right. All right. So we have 2 times the sine of x minus 1 equals 0. Solving of these equations for you guys should be relatively quick. Add 1, divide by 2. I'm hoping. So what angle will have the inverse sine of 1/2?
Angle 30 or pi over 6.
So it's going to be a pi over 6 angle. So we place it up. We have our 30, so it's 1, 2. So it's pi over 6. What other quadrant is sine positive?
Second.
Second quadrant, because the sine is your y value. So you're at pi over 6 and 5 pi over 6. Now here's where it gets a little bit different. In this case, we have 2 possible solutions. To get from pi over 6 to 5 pi over 6, you add, I'm sorry, did I write over, I meant over 6, sorry about that. You're adding 4 pi over 6. You okay? Now to get back to pi over 6, you got to add a whole lot more than 4 pi over 6. So are those 2 points always going to be equidistant to get between the 2? So when that happens, that means you tack on 2 pi. Because to get from here is 2 pi. Because it's not pi over n because you don't have something drop to the 3rd quadrant. Okay? So to come full circle, you're adding 2 pi. Same thing here. To come full circle, you're adding 2 pi. And it's a matter of plotting it within your quadrants to identify how fast your revolutions are coming around to make it work. It's not that bad, is it? It really isn't.
For the 45-degree angle one, if it wasn't plus or minus, what would it be?
It depends on what if we want to be in a positive or a negative. Because if it's a 45 and they're positive, then you're looking at first and fourth. So then it would be plus 2 pi n for both of them. If they were negative, it would have been second and third. It would have been 2 pi for both of them because they're not opposite each other. When you have sine, or unless if it was cosine, if it was sine, then they could be, then it'd be pi's because they're opposite on the diagonal. So you have to play with your signs, your SIGNs, with what quadrant things are positives and negatives. Okay, that's a good question. Take a second and try this. Okay? Walk through this real quickly. So we plot it, hypotenuse of 2 adjacent of root 3, which means I'm at 30. So I'm at pi over 6. Secant is the inverse of what?
Cosine.
Cosine. Where else is cosine positive?
Fourth.
Fourth. What is the value in the fourth quadrant then?
Plus or minus, so it could be anywhere, can't it?
Oh, I'm sorry. I forgot there was a plus minus there. Sorry. Yeah. So we're here. Sorry. I forgot that it was plus minus. So in this one we're at 11 or pi over 6,
And 5 pi over 6?
and then we have 5 pi over 6. The other ones were 7 pi over 6 and 11 pi. What can I do to simplify my solution here? Pi over 6 plus pi n. Very good.
So you don't need the 7 pi?
Nope. And a lot of times what I do is I list them out, and then I'll check, okay, I don't need this one because I can be pi n. I don't need that one to be pi n. And that's fine. If you want to list them out just to check where you're at and just cross them off, it's no big deal. It's not make a big deal at all.
Are
Okay?
we ever going to subtract these, or is this strictly addition?
What do you mean?
Like, are you ever going to do pi over 6 minus pi n, or is it?
Oh, we're positive thinking people.
I'm not.
So we're always looking at positive revolution, okay? We're always looking at positive revolution. Write down there. I have one more quick example here, because I know you guys are all getting ready to fail on me. Yeah,
So like half an hour.
I take it to the homework there next thing.
yeah, it's just that. It's the same section. I'd have to take it up. All
I
right.
mean, I thought.
One more. It's you'll figure it out. I hope. Yes, sir. Oh, take, hey, Zach, did you leave? Anybody else leave an early, say that earlier meeting?
Really?
Would you mind, did you take a picture of the homework problems? Yeah. Thanks. Take a picture. I don't know. Oh, where was it? I just had it down. Bless you.
Is this where it's like divide cosine by sine and get tangent?
No. What happens here with some of these problems when you have a subtraction symbol between the two. What you guys would do a lot of times, and we kind of shown it once that it worked, but the real way to do this is to factor. What do both of those terms have in common? A cosine. You're going to eliminate a possible solution when you do that.
Okay, so that's, there's still other solutions.
Right, but then you don't get all the right. Do these guys have the same value? Do these guys have something in common?
They both like it.
We watched this video on biology the other day, and there was this guy who was really obsessed with whales. And at one point, he went to the Sahara and desert, and he was like, "This desert is full of whales." Stop laughing. They weren't really whales, but they were fossils.
Now think about when you're working with factoring and you have something set equal to 0. When you have two terms set equal to 0, what do you do?
Divided by term.
What's cosine divided by cosine? One.
Why would it be in this way?
That's how it started.
Yeah, but how did you get back over there?
Wait, nothing equals 0. This is quadrantal, right?
What happens here, no, all you're doing here is you're factoring out what do they have in common. If this was 4x minus 2, you could factor out a 2, right?
Does that mean you have to make cosine?
It's the same basic idea. It's just with letters. What we're doing here is
Oh, I see, sorry.
if you had 4x squared minus x equals 0. You couldn't add x divided by x because then you'd lose a solution. Here you're taking out the value of x and having the 4x minus 1. And then you have to set both terms equal to 0. We're doing the same thing with sines and cosines. Okay? So in this case, you wind up with two problems eventually. You have cosine of x equals 0, or sine squared of x minus 1 is 0. Yeah. So this is asking you what angle has a cosine of 0? Well, you're right. It's a quadrantals. Cosine is 0, 1, and 0, negative 1. What is the angle measure there? Pi over 2. And to get to this one, what would you add to it? Plus pi, right? To get down to the other one. So my solution here would be pi over 2 plus pi n. Oops. Now when I do the sine squared minus, or sine squared x minus 1 equals 0, I add 1 and take the square root. So what values have a sine equal to plus or minus 1? It's quadrantal again. Isn't it the exact same thing?
Yes.
So in this case, my solution to both of them is pi over 2.
So you could eliminate the other, but on other questions, you might have two different.
Yes, in other questions you might wind up with two different solution sets. Because it's the same idea of factoring. X could be 2 or x could be negative 3. It's the same thing. We'll start to get more and more into this little funky town as we get into, why don't you get me to funky town? Thank you. Of course it is. So, yes ma'am.
I thought cosine was on the x-axis. Like, why is?
Yeah, it is. Where is x equal to 0?
Oh, okay.
Where is y equal to 1 or negative 1?
Okay.
Should I raise my hand again?
Oh, negative.
I do not compute. Danger, danger. Thanks. Same page before what you guys did yesterday. Yeah, add on to it, just collect it all at the same time. See if we, in case you screw something up.
Rip it out this time.
We'll do those, please.
Oh, sorry.
On Monday, we will start with our verify, simplify part of 14.3.
That's like 5.
It is.
Probably not next week, but probably the week after. So I want to finish all of 14.3, and then we might do one giant trig unit test, and then do a unit or it's like a quiz-am, if you will, on just graphing.
If I run out of
Are you not here again on a Friday?
I'll be on the beach.
Wait, she's here today.
Mr. Martinez.
Serious.